Welcome. My name is Bob Tickleman. I'm a Microsoft technical trainer. I'm excited to be your guide for Module 2, Run Container Images in Azure Container Instances, which is part of the Container Instances module in the AZ-204 course. We're going to dive now into specific instances or a solution within Azure that you can deploy individual containers. In another recording, we talked about the overall concept of what a container registry is and what a container is. And I'm going to pick up on that discussion very quickly, and we're going to do a demonstration of where this fits into the spectrum of container solutions that Microsoft offers. We're going to go into the portal, and then we're going to come back to the learning content and catch up and get the specifics that might not have been covered in the demonstration. But we're going to take a look at a feature of Azure called Container Instances to deploy individual containers and the management capabilities around that container itself. So we're going to jump into a whiteboarding session right away, and we're going to then go into the portal to take a look at this as a way to maybe start a migration to a container solution when you're maybe used to using traditional application deployments. In another recording, we talked about this whole concept of what a container is, and it's a modern way of deploying an environment space for you to be able to run your applications, as opposed to the old traditional monolithic way of deploying applications on operating systems. We then migrated over to virtualization, and now containerization is often used, especially in the microservices model. So just to make sure that you understand where we're going with this, is we had a thing called a container. And it takes together your code, which exists in some repository, whether it be GitHub or an Azure DevOps repo. You then had container images that you then had in some repository as well. And that was done in this other recording that talked about building a container registry, whether they be publicly available or privately managed. What you have is blank images or copies of what a container might look like. We talked about just a generic container, or maybe you've got multiple different containers that have different tools and pieces that were put into them. And then through a thing called a build process, which was that YAML file that you had, and we'll be talking about that in this module as well, that it grabbed a container, it grabbed your code, and it then deployed that container. So now you have a container that is running your code, which has all intents and purposes your application that's running. Now that container exists in a construct of a thing called a pod. Now a lot of people who talk about containerization, they don't actually get into this level of the pods. They just always refer to it as a container. Now you're going to hear me use the term called a sidecar. In the other recording, we talked about maybe having multiple containers in the same pod, and they're going to share the same resource space and the same number of resources. So the pod in here, we might have 2 cores that you're allocating for it, maybe 4 gigabytes of RAM, and then the containers that are in that pod would share those resources. I also drew the analogy to another recording that we had when we took a look at app service plans and how they very closely mirrored this whole hierarchical structure. Inside of a pod, that pod then ran inside of a thing called a node, which for all intents and purposes is that virtual machine. And you could have multiple pods as long as you had resources to run them on that node. And then as that node filled up, you had a pool of nodes that would then provide that compute capacity to deploy your applications. And so we then talked about the difference between orchestration and the containers themselves. And I want to pick that conversation up at this point. So within the Microsoft sphere of Azure, we have several different components to be able to provide a container environment for you. We have container instances. And that's what we're talking about here. Now, the orchestration or the management of this is basically going to fall on you. There's no real orchestration. They are literally that. They're standalone container instances that you can now use to deploy maybe just a simple application. Maybe you're not very deep into your container journey, and you don't want to take on the whole burden of being able to understand whole Kubernetes orchestration components that go with it. but I want to start this journey and I'm going to start to deploy a container. And so a container instance allows that to happen very easily and simply, but the orchestration is going to be on you, and you're going to see that in this module. I'm also going to jump out into another feature that we have called App Service Plans. Which we covered in detail in another recording, but I'm going to jump out and show you can actually have a container that is a standalone container, but it's now part of an app service plan that you now have a container running in that. So the orchestration is going to come from the app service plan. So if you're familiar with app service plans, this might be an easy way for you to get into containerization without having to understand all the orchestration pieces like Kubernetes. If you're familiar with app service plans, you could then start this journey of migrating over to a container environment. Now, we're going to then take a look at container groups, or a feature called container apps. In container apps, the orchestration is going to come from the container application, and you're going to get basically Kubernetes Lite. Where the orchestration is going to come from an underlying Kubernetes infrastructure without you having to manage all of the Kubernetes infrastructure, you're going to get some of the orchestration coming from this feature of a thing called a container app. And then the final solution that you have is an AKS solution. A full AKS solution, I'll do that in another recording when we cover the container apps. So it's not going to be covered in here, but know that those are the 4 ways that you can get either a standalone container instance, you can get a container app running multiple container, but with the light orchestration, you can get a standalone container as part of an app service plan, or you can get a full container environment managed through an AKS solution. So moving over to the Azure portal, I want to run a container instance. You'll see here that I'm going to be able to pick up the typical things that we have to build when we build a resource in Azure. I have to give it my subscription. I'm going to add it to a resource group, either by creating one or if I have an existing resource group. And then I have to have the container name. It can be whatever you need to be. This doesn't have to have some of these unique namespaces that we've seen in other resources. I'm going to just call it AZ-204 demo. What region do I want to deploy this? You'll see that we have a lot of resources that are regionally based. And we saw when we took a look at Cosmos DB, that was a global resource. And later on in other recordings, we're going to talk about Microsoft Entra ID as another global resource. But I'm going to deploy this into a region, and know that all container images are going to be available in most regions you're dealing with. There may be some slight differences of the size of the containers that you're working with, but with a lot of these resources, sometimes the caveat that Microsoft publishes is not all resource types are available in all regions. But what we're talking about here, the vast majority of it is going to be available regardless of the region you're working with. We took a look at availability zones, and this comes from another conversation that we had. We talked about Azure regions. Within a region, you have multiple data centers. And if it's supported, and this is one of those caveats that in not all regions support zone redundancy, in the case of US West 2, it does. If you go to some regions, they may not support zone redundancy. And this is where you're going to be able to pick which zone you want this container instance to run in. We then get to pick from a series of SKUs or stock keeping units. We have standard SKUs or confidential. These are specific SKUs that are going to be made available for you. And then where do I get my image? So this goes back to that container registry that I talked about at the whiteboarding session at the top. I can use a quick start image. So Microsoft makes a series of these images available for you that we maintain. So you don't have to build your own container registry. Or I can go to a container registry of my choice where I have built a specific container images and maintain them in my own repo. Or I can go to another registry. I think I showed in another recording that there is the Docker Container Registry as a public registry that you could pick this from. So I'm just going to show you one of the quick start images that we're working with. And then what you have to do is pick which image you want to work with. Is it a Windows or a Linux-based distro that you're working with? So I'm going to just grab a Linux-based one. And then what size do I want? Remember, we talked about that pod being the resource allocation that you're working with for the containers that are inside of them. It makes it look like you're actually deploying these resources to the container, but in fact, they are the pod-based resources. You can have as little as 1 core up to 32 cores. You're going to start off as little as 1 gig of memory up to 256. And some SKUs actually supports GPUs. So these become the resource allocations that you're going to deploy to the container instance that you're then going to deploy some code to. Now remember, this is just the space in which your application is going to run. I have a networking tab that I can work with some networking, so I can put it into a subnet, because remember, all of this orchestration is going to be coming from you and your management. But this would then allow me to build an individual container image to be able to run my application. So while we're waiting for this to deploy, I want to show you another form of an instance of a container, but this time it's being run through the app service plan for its orchestration. So it's kind of a compare and contrast. So I'm going to come to an app service plan. I'm going to create a web app. And you'll see that I can now run a container in here. So I'm going to just call this AZ-204 CI demo. What you're going to be able to do instead of running code, so if you take a look at another module that we recorded, we talked about the app service plans and being able to run in different environments. I'm now going to run this in a container, not part of the course, not having the course material go along with this, but very similar to the container instance that I just built. I can base it on Windows or Linux, and these are currently supported versions of these operating systems. I pick the region in which I want to deploy it, but here is where the orchestration is going to come in. This standalone container, very much like a container instance, as opposed to being administered and orchestrated by you, it will now be part of an app service plan. And if you remember from the recording on the app service plans, we talked about an app service plan allocates the resources, so how much CPU and memory it's going to get, as well as some features like scaling. As that resource becomes consumed, do I create multiple instances of that, either manually or through an automatic scaling capability? Does it get deployment slots? Is there automatic backup? So I'm going to get some light orchestration coming from the app service plan. So just a bit of a compare and contrast, really not part of the course, but I wanted to give that to you. Okay, we saw that in the demonstration. A container instance is a way to deploy a standalone container. And all those characteristics, well, you're going to allocate the CPU, the operating system, the networking features. All these characteristics that you're seeing on the screen are the attributes that you need to administer around that container instance so that you can deploy your application into that container. Remember, you are providing all this orchestration. We do have the capability to create what is called a container instance container group. Now, there are two ways to do this. It can be done through the YAML build process, but this is a way to deploy a grouping of containers. And you'll often hear the term called sidecar. So maybe you've got a monitoring tool that's going to monitor your application to see how well it's performing. I want that monitoring piece, sidecar, which is going to run in a separate container, but it runs in the same memory address space in that same pod that we had for the application that I'm deploying into my container image. So a container instance can actually run in a thing called a container group that shares some common resources. They get some common orchestration because as you orchestrate the pod, because they live in the same pod, they're going to get that same level of orchestration. I don't have to have this high level of networking because they are deployed in the same local host address space that they're working with that they can communicate through. So again, just covering some of the concepts that we covered before, how you deploy this. It can be done through the portal. It can be done through ARM templates that you're working with. Different ways to work with this. The resource allocations, we talked about the resources that you're deploying to the container instance. They can be changed after the fact, but no, it's going to cause the container instance to be re-imaged. So it may cause a potential interruption to the running of that application. We get networking features. Now, there is some storage that's available for the container to run in, and we saw how much memory it had, but remember, that is volatile memory. And so if that application or that container instance goes away, whatever's stored in that memory will be gone. So you can make it durable storage, like you would with most container management. You've got to offload that to some form of durable storage. In this case, we often refer to file share storage as part of a storage account as one way to be able to do that. So I can now connect to a file share and then store that information durably. Maybe I even go to a storage account, put it in table, Cosmos DB, different ways to make that durable for you. One of the features that I didn't go through that you can actually enable on the container is what is its restart policies. And so you have a restart policy that says if that container were to hang or whatever, it needs to always restart. Does it never restart? On failure, does it restart? So you do have a reset policy to provide some level of automation. But again, you are setting it up and it will only behave based around the characteristics that you define in that reset policy. We talked about passing off environmental variables. I showed you in the build process, there's some of those that you can work with. They can actually be part of the build process in your YAML file of deploying of the, if you're going to use a template to deploy the container instance. I'm going to be covering in another recording how to manage these variables across a series of environments that you're working with in another recording. So I'll leave some of that for deeper discussion later. So we mentioned a way to be able to make your information durable was to mount to a file share. And so there's several ways that you can do this because it is stateless. If that container goes away, anything in its memory goes away, we need to find a way. File shares is typically the best way to work with that. And so you're just going to see how to mount a file share and be able to communicate with writing that data off to that persistent storage. When you work with YAML, as I said, this is the file that is going to be used to build that initial volume. You could mount that volume through the YAML build process. I didn't do that in the graphical interface, but most of these are going to be built through a YAML build process, just like you would for most containers. You can actually mount multiple volumes if you're working with, so that's an option if you need that kind of storage. And this is going to get us to an exercise where you're actually going to go through and create a container instance. You're going to deploy an application to that container instance, and you're going to see it work in a container group to get some functionality in a cloud-based deployment.
In this lab, I'll deploy and run a container in Azure Container Instances, or ACI, using Azure CLI. I'm already in Cloud Shell, so I'll just start setting up the environment. The first thing I want to do is to set a DNS namespace to expose the container to the internet. What I'm now doing is deploying a single standalone container in West US2 with one CPU core, 1.5 gigs of memory. You can see the names and the other features that are going into it. So now that it's been deployed, I want to just check on the provisioning of the container. And I've got there's the URL that I'll be using to access the container. I'll open up the resource group so we can just take a look at the resources in it. And there's your container instance. And again, there's the FQDN that I'll be pasting in. And my container's running. So we deployed a standalone container, put a small app in it, and we accessed it. That's the end of the lab. Let's return to the recording.
So welcome back from the experience of actually working with deployment and use of a container instance. Let's close out the module with our regular knowledge check. Question number 1, what method is recommended when deploying a multiple container group that includes only containers? Go ahead and pause the recording. And you saw me do this in the demonstration. Some of those features weren't available in the portal, so you're going to want to do this through the YAML build process. Question number 2, what is the purpose of the restart policy in an Azure container instance? Go ahead and pause the recording. As we described, a container instance provides no orchestration. It's up to you to provide the orchestration of all the components needed for the container. And a restart policy just allows you to control what you would like to have happen in the case of the running of that container itself. What happens in the case of if it fails? Does it restart or not? But it provides you the capability to provide some orchestration around the management of that container. So as we continue a journey on containers in general as a modern way to deploy services and applications, we see that Azure provides a wide range of these capabilities, starting with a container instance to have individual containers if you are early on in your container journey. You don't want to have to go through to the high-level container management features of orchestration with an AKS solution or building them yourself. A container instance allows you to start that very easily with a light set of orchestration that you have to then provide. You have startup capabilities, but it behaves just like any other container, just that they are standalone, and you get that whole usage of individual containers per pod. You can have multiple sidecar applications that get deployed with your application into that pod, sharing those resources that you're working with. So that completes part of the journey of our container process. Thank you for joining me in this, and I look forward to seeing you in another recording.